Today I'm going to be just working with complex numbers, converting between what's called rectangular and polar forms. So complex numbers are numbers that can be written in the form a plus ib, where I is the imaginary number square root -1. And so this is a and b are in the reals. And so so we're just going to be converting this format into another format called polar form. So this is rectangular form to polar form, which is of the form r times e to the I theta. Don't worry about where this came from for now. That'll be a later course. But yeah, so the relationship between, I'll just let you know the relationship between these two, and then we'll do an example. So first, if we start off with rectangular and we want to get to polar, what's this number? This number is the magnitude of the complex number. So what's great about this is if you think about these as the sides of a triangle, right angle triangle, then we have Pythagoras and trigonometry to help us get this r and theta, which is magnitude and angle. So first of all, r is the length of the hypotenuse of this triangle, which you know from Pythagoras, the identity or equation, r squared is a squared plus b squared. So we can easily just square root both sides, and then you have your magnitude of the complex number to put here in the polar form, and the angle will be this one here, which it can be found using your sine cos tan. Probably if you've got these two numbers already, tan is the easiest. So theta will be the arctan of opposite, so b over a. Right, so that's how you can memorize these formulas, or once you've done it a few times, it will become easier to just recognize the triangle and the trigonometry. Alright, so for an example, in rectangular form, we'll start with a number z is equal to 1 plus I root 3. Alright, so we have real component 1, imaginary component root 3. So we put these into the triangle, which is 1 here, root 3 here. So 1, root 3, approximately. The drawing of the triangle doesn't, it's just freehand. It doesn't have to be to scale. But the numbers, when you use your this formula, so we're looking for the r first. So r squared is a squared plus b squared. So you got r squared is 1 squared plus root 3 squared, which is of course 1 plus 3, which is 4. And so you square it both sides, and your r is equal to 2. We take the positive value because it, when you think of triangle, it doesn't really make sense to have negative magnitude. So we take the positive value of 2. So we can put this in here. So we have, going to polar, we have the first element, which is magnitude, 2. And the last thing we're looking for is this angle here. Alright, so then we come back to our tan to find the angle in here. So we have theta is equal to arctan, tan -1, of b over a, which is our root 3 over 1, so arctan of root 3. This turns out to be a nice fraction of pi. If you remember your triangles, such as your 1 to root 3 triangle, then you can, from like other high school maths you might have done, the angles in here will, just forgetting about complex numbers, just this triangle, the angles in here will be pi on 3 for this one, pi on 6 for this one, which come out to 60 degrees and 30 degrees in degrees, but radians works just fine. And then back to complex numbers, this one will actually be our angle here, which is indeed arctan of root 3, which we can then put up here. And we've completed the transformation from rectangular to polar form for this specific example. And